right, the video you've all been waiting for on associations in data. So I'm going to go through all three objectives fairly quickly, but all of this information is in the platform. So if you need some more practice or notes or anything, just go look in the objective you need help with, or you can email me and I can help you. All right, so starting with objective 1. We're going to talk about correlation of data. So all three of these graphs show a positive correlation. Things to notice, all three of them are increasing and going up, okay? This means that they're positive. So they're increasing, they're going up, that means a positive correlation. Oh, we skipped negative. Okay, negative correlation means they're going down. I want you to think about slope in this, right? Slope is going down, it's negative, right? So it's the same thing with correlation. So all three of these examples are negative correlation. Now, these are considered no correlation because you can't see a pattern or a trend at all. They're just kind of all over the place. The last kind of correlation I want to talk about is a nonlinear kind. So notice that both of these curve. So if they don't create a sort of straight line look, then they're considered nonlinear. Basically, if they look like they could form a curve, they're nonlinear. So this is still a positive correlation, but it's considered nonlinear. And this one is still considered negative since it's going down, but it's nonlinear. Remember, linear just means a straight line. All right, 2 vocabulary terms we need to talk about with objective 1 are clusters. So clusters are a group of points clustered together. They look similar to these guys right here. So if you see points that are really close together and kind of staying in the same way, it's considered a cluster. The other vocabulary term we need to talk about is an outlier. An outlier is an extremely high or low value that does not follow the trend. So if you look at this guy right here and this guy right here, you see the other points are all following a trend. This is a negative correlation, but here's this random point out here doing its own thing. It's considered an outlier. Same thing over here. All these points are following a positive correlation, and then here we go. Here's an outlier. So if you see a point off to itself, you're going to kind of ignore that, especially in the next objective, which is where we're drawing trend lines. So he's just, out there doing his own thing. He's an outlier. All right, objective 2 is about trend lines. So we're still using those scatter plots. So a trend line or line of best fit, that's another word for it, is a line that approximates data points. So you want to make sure that your line passes through the points and does not lie completely above or below the points. So if you look at these 2 examples over here, this is a bad example. This line right here lies completely below all of the points. This one lies above 1, but below 4. So it's okay. It's better than this one, but it's still not great. Let's keep going. You also want to make sure that your line alternates between passing above and then below points and doesn't simply go above some points and then below the rest. So this one's above 1 point but below the rest. Look at this one. He's trying to be below these 2 and above these 3. So this is a better example. Last, you want to make sure that the line goes through the middle of all the points so that it is a close to all the points. So this was the better example. This one is the good example. So notice it's not, it's kind of trying to split. So it goes right through the middle of this set of data. Okay? All right, now I want to show you how to use, a trend line on a question that might be on the test. So first, I'm going to get out of here so that we can draw a trend line. Before you start your assessment, you can open this program. Everybody has it on their school device. So if you're taking your test on a non-school device, then you may not have this. So you're going to open Active Inspire. Y'all have seen me use this at school. It's the one where I draw on the board, but we're going to use it for another reason. So you're going to click Close. Yours might take a minute to open the first time. It takes a few minutes to load up. There's probably something over here on this side. There's a little red X. Just click it. Then you want to make sure you're on the little mouse. And then you want to click this blue box with the squiggle. And that's where you can draw on your desktop. Now, once you have this open, you're going to read your question. The scatter plot below shows the price of different weights of several bulk grains. Using a trend line, determine the cost of 2 ounces of grain. So to draw a trend line, remember we want to draw a line that goes through this. I don't suggest you using the pen because if you use the pen, it's not usually a straight line. It's hard to draw on your computer. So if you click this little shapes tool down below, you've got these line tools. The first one is the one you're going to want to use to draw your trend line, and it's going to create a straight line. And remember, you kind of want to be in the middle of the points. Now, this says determine the cost of 2 ounces of grain. So I have price on my y-axis and grain in ounces, weight in ounces on the x-axis. So I want to know how much it costs for 2 ounces. So I'm actually going to switch my lines. If you look right here, I'm going up to 2. Now, what's cool about these is no matter how far you veer off to a direction, it's going to stay vertical, okay? Now, I went up to my trend line, and now I'm going to go over to the other side of the graph with the horizontal line. So I see I'm about, if this is 40 cents, this is 20, I'm at like 25. So now we're going to use our best judgment and estimate. Remember, your trend line is not perfect every time, so you're going to use your best estimate. So between the answer choices of $20, $16, 30 cents, or 40 cents, well, it's not 40 cents. It's not close to 40. So I'm going to go with C, 30 cents. So that's how you would use a trend line to answer a question. This question is actually on the diagnostic, so I pulled straight from the test. And to get rid of these, you can just click the back arrows. All right, that's objective 2. All right, objective 3 is mean absolute deviation. This is completely new. You know how to do the mean, but this is like 3 steps further. So to find the mean absolute deviation, here's an acronym right here that'll help you remember. It's called MAD-SAD. MAD is mean absolute deviation, so just telling you what you're doing, okay? So to do the mean absolute deviation, you're going to add, you're going to divide, then you're going to subtract, and you're going to add again, and then you're going to divide. So we're going to use those steps and solve a problem, okay? So I'm closing out. And here's my example. Okay, so I've written MAD-SAD up here at the top just so we can remember. Remember, this is just telling us we're doing mean absolute deviation, so I'm really following these steps right here. So we're going to add, divide, subtract, then add again, and then divide again. Okay? So first thing I want you to do is write these numbers out vertically. 7, 12, 10, 9, 9, and 7. Okay? So next, we're going to add. So I'm going to open Desmos, and I'm going to add these numbers up. They equal 54. Now, the next step is divide. This is where it changes from problem to problem because you're going to divide by the number of numbers. So we've got 54 divided by, there's 1, 2, 3, 4, 5, 6 numbers. So divided by 6, and that's 9. Okay? So we're going to subtract now. You're going to subtract that number from every number. Now here's where I see mistakes. When you subtract 7 minus 9, you actually get -2, but we're ignoring the negative. We're just going to write 2. 12 minus 9 is 3. 1. That's 0. 0. 7 minus 9 again is -2, but we're going to use 2. Okay, so we added them up. We divided. We subtracted. Now we're going to add them all up again. So I've got 2 plus 3 plus 1 plus 0 plus 0 plus 2. So we get 8. And then the last step is to divide one more time. You're dividing by the number of numbers again. So 1, 2, 3, 4, 5, 6. So 8 divided by 6. So that means your mean absolute deviation is 1.3 repeating. Okay? Now, something else I want to point out. If this number, if you had, added them all up and divided and gotten a decimal, you would need to subtract the decimal and use those decimal answers. You can round to the nearest tenth on these. Okay? If you need to see another example of this, Just look on YouTube for it. But I can make another one if y'all need help. Good luck!